So we're just going to have a education tonight. You did the report already? Oh, wait. So for those who don't know, we're going to record tonight's presentation. The main reason is that we want to try and provide the members with access to our education nights. And the best way to do that is to record it, and then we're in the process of updating our website so that members have separate access to special back pages so that they can go in there, look at all these presentations, and obviously see the video from each presentation on education night, and that way they have access to it, because it is quite difficult. Obviously being in Sydney, having being from the country, as well as there are members interstate. So those that are on the website tonight, welcome, and hopefully get something out of it tonight. So tonight's presentation is by Jim Monday. Just a quick bio on Jim, if you didn't see it. Jim's a forensic chemist, member of the Institute of Fire Engineers, holds a Forensic Science Society diploma and in fire investigation. He's also accredited as a postgraduate diploma from the University of Strathclyde. He's also a certified fire investigator through the International Association of Arson Investigators. And tonight he's been certified for a number of years, only one of 4 in Australia. He's widely sought after as a writer and speaker internationally. So tonight he's going to talk about heavy equipment, fire cause determinations. So thank you, Jim. Welcome. And let's start. Thanks, Jim. Find on time, please. Hopefully the recording will pick up the voice of nice loud voice of Jim. And if you do have any questions, speak nice and clearly so everyone can hear it through the mic. Thank you.
Okay, good evening. Thanks for the invitation, Steve. And if anybody wants to ask a question as we go along, that's great. You're welcome to wait till the very end, because sometimes they get lost in the document. I would just ask you this moment, if anybody's coming in with a cold beer, please get your in, because I don't want to be distracted. Okay, so what do I mean by mobile heavy equipment? So that's probably a good place to start. It's all brief. It's not about the sort of machinery that gets involved in things like mining, civil engineering projects, road building, and some heavy transport. So there is an example of like road train, like prime mover. Basically, most of this though is off-road equipment. Equipment designed to be used in off-road situations for heavy movements of stuff. So I'm going to quickly run through some of the operating parameters of these things, because they're a bit different from most road vehicles. So if you're not familiar with them, it can throw you a bit aside. Okay, so this should be working. Okay. For a start, there's a number of different power and traction options on most of these machines. Diesel, mechanical, so diesel engine with mechanical transmission, mechanical power plant. They're generally lighter duty things, so they're the sort of things I would describe as mainly road transport. In mechanical, I include sort of automatic gearboxes and traditional torque converter types with fluid in them, but they still become as a mechanical type gearbox. So they tend to be used for lighter duty things up to and including sort of road transport. Once you get heavier than that, the main combinations are either diesel or hydraulic, where the diesel engine drives a big one equal a series of big hydraulic pumps, and then that hydraulic fluid doesn't work through the machine, so it provides the motive power that goes through it. Hydraulic motors drive the wheels on the tracks, and it also provides the suspension and the steering and all the other brakes and all the other functions of the machine. You can get diesel electric, and these are actually becoming more and more popular for various reasons with the haul trucks. We'll see some haul trucks in a minute. In the diesel electrics, what happens is the diesel engine drives a big generator that generates high-ish voltage, medium high voltage, alternating current, which goes through control systems and then powers the wheel motors. Each wheel has a separate motor. and the wheels are basically operated by computers, and they have certain advantages for certain operating conditions. But even the diesel electric ones will still generally have a lot of hydraulic pumps, because the hydraulics still run functions like the brakes and the steering, and so on. As well as hydraulic braking, the electric ones also have electric retarders, so that the initial braking is usually done by the electric motors acting in reverse. So when you want to brake, the electric motors act like operators, generators, and they'll slow the thing down. There will be hydraulic braking either as a last stop or as an emergency stop again. As I say, these things have all got advantages and disadvantages for the users, but they've also got advantages and disadvantages for the investigator. One of the advantages, obviously, for a diesel hydraulic system, for the investigator, is you don't have to worry about high voltage electrics. You've only got to really worry about normal 24-volt DC electrics, the same as you get on any heavy truck, to start the engines and run the lights and that sort of thing. So you don't have to worry about any high voltage AC applications and that sort of thing, which you do on these diesel electric ones. On the other hand, on the diesel electric with the electric retardation, you don't have friction heating on brakes unless there's a problem with the hydraulic emergency brake. So it's one less thing to worry about usually, but if you've got fires around the wheels, you don't so much have to worry about the possibility of friction heating on the brakes, because if they've only been running on the electric retardation, there's no actual mechanical contact going on the brakes. Okay, so some of the challenges. Well, most of the challenges are, first of all, a lot of these things are in remote areas. They're being used in remote areas. They're not accessible to normal firefighting equipment, and very often the only firefighting that gets done on these by the water car that has to be used on the site, and sometimes even that isn't applicable because tyre fires are a big hazard with these things, and once the fire gets into the tyres, it's in danger of explosion. The beads come off these tyres, the big iron beads that go on the wheels, they can go like 300 to 400 metres and kill people. So they usually have a 400 metre or so exclusion zone around it. Once the fire progresses to that stage, they just let it burn out. So immediately we then have a disadvantage or a challenge for the investigator, and the damage is a lot worse than it might otherwise be. A second challenge very often is the sheer size of the thing. They're generally pretty big, most of these bits of equipment. So climbing around them and getting underneath them and that sort of thing is actually physically very difficult. And the third, and probably the most important one, is that, particularly the first few times you do it, everything is unfamiliar. Unless you've worked on these things in some other capacity, you're familiar with this sort of machinery, it's all unfamiliar. You know, we've all been under the bonnet of our car, and we've all been, poking around in a light truck at some point or another, but these things are on a whole different planet, So the problem is that very often you don't know what you're looking at. So to start with, I would say that you have to be able to know your information sources. So good information sources, generally, if you're working in a mine site or a civil engineering site or something, there will be people there who really know their way around these things. Mechanics, technicians who really know their way around. Take advantage of that because they will tell you what everything is and everything does, how it relates to each other. Obviously, if you can get hold of service manuals, service histories, logs, usage logs, that sort of thing, most reputable firms that are doing this sort of thing keep immaculate records of things like the operating hours of these machines, because they have to be serviced at very specific intervals, exactly what's done on servicing, exactly what's been replaced when, and so on. So they keep very good records. The other thing that I would say is that a lot of these files, particularly these days where everybody's carrying mobile phones, are very well recorded as they happen. Even before, or particularly before the exclusion zone is put in. So very often you'll find that once the fire is, immediately the fire is started, somebody somewhere they've got their phone out, the video and everything that's going on. So getting hold of those videos and early stage photos can be really, really helpful when you've got something just completely burned out. That's exactly the same as with any other fire, really. The other thing that's worth looking for and always asking for is intent files of the same type of machine. Those are the organisations got more than one of the same kind of machine, and if they can show you an undamaged one alongside a damaged one, it really does that. So I thought what we could do tonight is just run through a few a few case histories that turned out to be fairly simple, and you can see some of the advantages and disadvantages of what I've just been talking about.
Yeah, for that. What's the sort of average dollar value you're doing?
Okay, the average dollar value for these sort of things, replacement cost would be, most of what we're looking at tonight would be in the region between $2 and $10 million. Okay, so the point is that a lot of these companies are running fleets of maybe 50 of these around the world. And if one of them catches fire here, they want to know why. Because the next thing you know is they've got 3 or 4 catching fire in other places, and they've got a real problem in their hands. So that's a lot of the reason we get involved. Sorry, I should have said that earlier. Probably the cheapest thing that you'll see on the tonight is a prime mover, which would come out around about 200 grand. But mostly, something like this, replacement value on one of these is about 5 million.
When you talk about the electrics, diesel electrics, and you're saying you've got high, medium to high voltage. So what's the average that's created?
Humongous. You're normally looking at the generators and traction motors are normally running at somewhere around 500 to 1,000 volts AC, depending on the system. And they're rated in the thousands of kilowatts, certainly high hundreds of kilowatts. So the current is going to be in the region of 700 amps plus. So you're talking about taking the stock high. This is just an example of the sort of thing that I was saying about getting early photographs. This photograph was taken by one of the workers. This is put out in an official report. But this photograph was taken by one of the workers on the site about 4 minutes after the fire was first seen on this truck here. I won't go into all the surface there. Some of these are actually, I don't give you permission to tell you about providing I keep confidential and anonymous. So I've got to be anonymous. So I can't tell you exactly when or where it's occurred. But suffice to say, this is what's called a go line, which is where the trucks come up to and they stop, or the drivers go, the operators go brake. While they're on their brake, a service car comes up and replenishes the fuel, the oil, everything else needs replenishing, and then when the drivers finish their brake, they come back, get on the truck, and they go. These trucks, buckets on them carry around about 250 metric tons of rock at a time. So they're a fair size, as you can see. Now what's happened here in this one is that a couple of go line, half of the go line, this one here has actually been refueled, and then the service truck is moved along to the next one, ready to refuel that one. But in doing so, and putting out hose and everything, a fire, a very small fire was seen about halfway back underneath that truck. This is the operator of this truck. He'd already dismounted once, but he went back when he saw this fire. He went back to try and get his truck to move, but he wouldn't start. Well, it was a very good reason he wouldn't start, because the service car operator had done the right thing, which is to what's called lock out. For safety reasons, when you're working, doing any work on any of this equipment, you have a locking out system. Individuals have individual locks. So the service car operator had done exactly the right thing, which was to lock that out. Of course, that meant he couldn't restart. So what happened immediately, despite the fact that the wind's blowing in that direction, as you can see, after a while, an exclusion zone was put in around this because the fire very quickly got to these tyres, and then within a relatively short time after that, there was a spread of fuel and radiant heat, full fuel on the ground and radiant heat as well. Ignited this tyre separator and then ignited that truck. So I actually lost about $10 million in the truck. So, we had quite a lot of information before we started as to where the fire was to the scene, and we also had another situation which was I had an identical truck right next door, which had also burned, but which I knew the fire didn't start. So I was able to do direct comparisons between damage on this truck, which was a victim truck, and damage on this truck, which was where the fire started. Okay, so for a start, so we're now looking at the photographs behind it. The fire, as I say, was first seen underneath that truck, approximately halfway between the front and rear wheels. And in that area there's some ducting that takes cooling air from a fan in front right through under the tub to this area at the back. This is the back axle, which is where the traction motors are. And they have to be kept cool. This is a diesel electric, this one. They have to be kept cool. And so there's a fan system flow there right through from the back to the front to the back. So one of the thoughts was had the fire starting in the ducting system, or something to do with the fan, and then some sweat back through the truck. That was something we could think about. There were other possibilities, one of which was that the truck had just come from tipping activity before it came up to the go line to drive the same brake. So one of the questions was, had that tipping activity been involved in any way, had anything happened to the hydraulics that actuate the tub? So we took soil samples from behind both these trucks. The idea was then to be able to compare the soil behind this one with the soil behind that one to see if there was any extra contamination from hydraulic oil as it comes to the stop. Now here's our victim truck. That's what it looked like after the fire. You saw earlier on what it looked like before the fire got to it. So the fire's hitting from this side, and if we click it underneath here, where all that ducting was that I told you about, this is the area that's sort of underneath the middle, and you can see this material here is the remains of this plastic ducting, and also there's a glass fibre shroud that goes around the fanning panel on the back of the generator. So all that's collapsed into that area. Well, when we picked it up, we found the ground underneath it actually burned. So the fire got underneath the truck before that lot came down. Excuse me, which is what I would have expected. I was able to see how the fire travelled through that dust once it had gone into it. This is looking up at that area there, and this here's the back of the generator, and this here is a succession of hydraulic pumps. It's actually two in a line here. This is the impeller with the remains of the shroud on it, and there's two hydraulic pumps. One of those pumps hydraulic fluid for the steering. Not surprisingly called the steering pump. I was amazed by that. And the other one provides the main power for lifting and lowering the tub. Strangely enough, that's called the hoist pump. So, having got my head around with the jargon, I was also able to look at an unburned one, and we're actually looking at the hydraulic pumps from a slightly angled one. But you can see basically what you've got is the system of pumps and pipes and joints and everything, and they're notorious, everything is notorious for leakage on these things. They do their best to they're working at such high pressures. Typically, these are working at 12 to 20,000 kPa. So it's a lot of pressure. So we're able to compare another damaged one with one that I knew had been subject to fire damage from outside. And then we went back to our origin truck. I'm coming a lot out of the story here, as you probably know. By now I've already done 2 days work on something like this. So this is our truck where we know the fire started. Similar angle to the other one. You can see that the damage actually, the external damage is not that different between the two. It's actually quite similar. But when we get underneath, it's very different. On this one, we had burned ducting but that was lying on top of this lump here, which is melted aluminium. And that is directly on top under the ground. So, in other words, that aluminium was melted and fallen before there'd been much of a fire under the truck. There's not been a small fire under the truck. So why does that aluminium, well, where does it come from? Why is it melted? Well, where it came from is this. So you remember what I said about the hoist pump and steering pump? That's all this section here. And that's all that aluminium casing. And all these steel bolts go through. So the whole thing bolts together in the end with the steel through bolts. The rest of it's all aluminium apart from impellers, which is also dropped down. I'll show you those in a minute. So we've got a heap of damage here, which we haven't got on our victim truck. Then the question becomes why. So, cutting a long story very short, this is one of the soil samples taken from behind this truck. And what we found when we analysed this soil sample was that the ground behind this truck, about 5 metres back from the truck, was soaked with hydraulic fluid, hydraulic oil, whereas behind the other truck wasn't. So that suggested to us we had a hydraulic failure before the truck even comes to stop the cover. So we knew we had a hydraulic leak. We knew that we had a lot of heat going on here at a very early stage. And then when we pulled it, we found the impeller, this floating impeller system, and that's basically a steel, contra-rotating steel cogs, switching fluid between them, and the whole thing was a complete mess, it really mangled in a bad way. So what this told us was that we had a failure, in fact, in the hoist pump. And when we went back and talked to the operator did in fact confirm that having done the tip just before driving down for the break, when the tub was on his way back down, he actually fell, lost a couple of feet, banged on the stops. He's not even supposed to do that. But he hadn't thought anything about it because he was actually going to cut the seat. So that gave us an idea that probably we'd have a hydraulic failure occur back at that point, which is about 200 metres away, and then driven from there with this hydraulic oil leaking and spraying because there was it would have been under enormous pressure and spraying out from various orifices. And because with these trucks, you've always got one major heat source, which is always there when they're running, which is a turbo fuel. And as long as the truck's running, turbo fuel is hot. One of the things about hydraulic fluid, the engine oil, and even diesel fuel, it's not easy to ignite when it's a bulk liquid, as you know, but if you form it into a mist, as you get under pressure, it ignites really, really easily. Way below its advertised ignition point. So it has an effectively reduced ignition temperature. When it's full up, that carries about 2,500 litres. And it carries 7,500 litres a day. About 1.2 metres. Now, a lot of the, in fact, the majority of the equipment has lagging on the turbochargers and on the exhausters. A lot of the operators think that the presence of lagging will actually stop ignition of vapors and mist, but it doesn't. It's always actually there to do. Lagging is actually there to protect operators if they have to get into that area on the engines to not just hold the servicing crews for that. The point about any kind of lagging or any kind of thermal wrap that you put on a system like this, bound to have gaps, and the atomized liquids, whether it's hydraulic, engine oil, diesel fuel, if it's atomized, it behaves very much like gas, and it will get into any gap that air can get into, this will get into. And if it ignites there, it does exactly the same thing as a gas, which is it flashes back to where the main source of escape is. It behaves exactly the same way. So if you get involved in one of these jobs and you're unsure about whether you can explain it to the hydraulic leak, think of your hydraulic leads behaving like a gas. And you know how gas leads behave, you know when they ignite, they sometimes flash back, and if you can flash back to where the escape is, if you look as if it's done that, then there's a good chance that that's what you're looking at. So that's that one. So we got the result from that. I wasn't very happy, but we got the result from that. And that's a certain amount of manoeuvring with their pump systems. But anyway, this is another haul truck. Slightly different set of circumstances, but again, this was a using the electric haul truck, and again in colour line, not in this country though. And what we've got here is a fire that's clearly starting. A fire is starting underneath here. The driver reported he was driving along, and his gauges, his pressure gauges, suddenly dropped back to almost zero. His hydraulic pressure gauges. He lost his steering. He lost his brakes. He had to use emergency braking to come to a halt. And then, as he came to a halt, there was a fire. This on this side here. This is the hydraulic fluid tank. Give you an idea of the size. If you want to ask about how much, that's around about the same size, about 1500 litres. And all that you can see, you've got a sort of a burn going up across it that way. You probably can't see so well. The burn is that side going that way. Everything's going on underneath there. And when we look back along the road, this is the haul road the truck's just come down. I don't know if you can see it, there's a big oil stain going way back up the road. There's big globs of oil, pouring oil out that's coming down the road. No, I put the place on this one, sorry. Oh, sorry, yeah, there we go. Yeah, so, yeah, here we are. So we've got oil here, there's actually oil way up there. We've got oil here, this is full of oil, and this is, so the truck is just stopped about it. So when we look underneath, we're looking in towards, just behind and beneath the engine. And I don't know if you can see, if you look at this area, it's heavily sooty here, heavily covered with thick soot, but here, it's burned off. These white areas where the soot's burned off. And if we're looking a bit further, you can see here, you've got some quite severe burning here and on these pipes. Now these are actually hydraulic pipes. Some equipment uses special hoses, some uses solid pipes, a mixture of the two depending on the application. More and more, the flexible hoses are a weak point, and everybody knows that. So more and more manufacturers try to put in really solid pipes as they can to cut down on the number of flexible hoses. So this was a recent model, and these on previous models have been flexible hoses, these pipes, but you can see there's a lot of damage here. And if we look closely, this is a bracket that holds these two pipes up to a member up here, a chassis member. And when we take that pipe off, we've got all this burning is here. There's very little burning on this side of that. It's all smoke deposition. But there's something, you can't quite see it because it's around the far side. I'll show you in a moment. There we go. You can see this pipe has got a split in it. And that's right in where the clamp sits. You see it's clamp, that clamp came round there and puts on there. So that split was concealed inside the clamp. You couldn't see it. So even if this vehicle, if this truck had been inspected before it went on duty, nobody would have actually seen that there was an incipient failure in that position.
That's a hydraulic one?
That's a hydraulic one. High pressure hydraulic one. So again, it's running at, I can't remember the pressure, I should have written it down. Very high. Lots of PSI. Yeah, something like that, yeah. So, we took the pipes completely off, these two pipes, and this is, each end has got a rigid mounting. And when you look at the rigid mounting at this end, that bracket is actually snapped and you could see that it was a fatigue fracture, and it just been vibrating like this until it snapped. At which point, the weight of those pipes was then hanging on that one clamp. That one clamp, oh there we go, this is the rib fracture. So it's here, so that's actually snapped through. So if we look at this clamp, you can see that it's actually not a complete clamp around both pipes. It's complete around that one, but there's a section missing under that one. There's a lever there. When you put it back into position, you can see that the grip that one was just sort of supported underneath, it wasn't gripped. So if there's a snapped off section at the other end, that whole pipe is then vibrating inside that clamp. Hence the split. So having come to that conclusion, I said, well, here's your problem. This is what's happened. It's dumping the world. Once again, turbochargers is the issue, so there's no problem with that. And they said, oh, well, that's interesting. I said, why? They said, well, we've got this other machine, as you can see, it's a simple machine, and we have a problem with it. And we started to get a crack in the pipe. So we welded a collar on it. Welded a collar around it. And I said, well, didn't it occur to you to inspect all the other trucks? No. I told you it wasn't in this truck. But here, on that same one, this is what that clamp is supposed to be like on that end. The one that snapped off on the other one. And when we looked at that one, sure enough, it was starting to crack as well on the chute. So it's actually, the builders of this machine have actually done too good a job of the work design. They've got rid of the flexible hose, which was prone to failure, and replaced it with the pipe. They only worked out what the stresses on the pipe were. In fact, the consequences were actually much more serious, because normally, if that hose, usually that your phone wouldn't have to stuff the oil and catch fire. But because of this, because of the way they install pipe, they make it a bit more pipe. Anyway. Okay, change of emphasis. Sticking with the theme of hydraulic oil, so here we go with our drill rig. This is the sort of thing that I use for drilling down into the rock to place an explosive shot in order to blow the side of the quarry off. This is a quarry. Pretty badly burnt out, as you can see. Most of the damage appears to most of the damage essentially in here. The engine sits back in here, the diesel engine. Then you've got your hydraulic pumps here, and all this area here is filled up with hydraulic pipes to do various jobs and solenoid valves and all sorts of control equipment. And basically drives this bit at the front, which is actually what shoves the drill to the ground. It's probably got a technical name, but I don't know. So we're looking into that side door, and you can see you've got this tangled mass of hydraulic hoses. Now, if you've ever seen one of these things working, I don't know if any of you are familiar with seeing heavy equipment like this working, but you'll see all the hoses are pulsing and moving all the cycle, jigging about, pumping around, bashing into each other if they're not restrained. And this thing was an absolute rat's nest of hoses. I've never seen a piece of equipment like it. At least in most pieces of equipment, they make some attempt to sort of lay it out neatly and restrain it somewhat. Not this one. So these are our hoses. So when we look down at the bottom here, this is looking down at the bottom of that section here. These are all very badly damaged hoses. But I don't know if you can see this running through there. Can you see that? That's a 24-volt DC cable, electric cable, from that runs from the batteries of the starter motor. And for some reason, the battery runs the front of the machine, the starter motor obviously is back to the engines. Cut off the wire. Interesting piece of design. When we look a bit closer, here's our cable running all the way through here. And our most badly damaged hoses are all in this area, all in the interior of the cable. Cable's not restrained, hoses not restrained. there it is running behind there and round behind these hoses. And here's a section of hose that was actually penetrated. Most of these hoses weren't actually penetrated, the grades were intact, except for this one. What we've got under a microscope, you can see that it's actually got a hole, that's broken file to file, but it's actually got a hole in it there. And under just fire magnification, you can see this is a hole. I don't know if you see these little dots. Little round bit there, little round bit there. Fire magnification, little round bit there, couple bits there. Little round bit there, little round bit there, some up there. They're like these, where the brain of the cable is actually aft against the 24 volt DC cable, sorry, the brain of the hose is aft against the cable. And obviously what's happened is that over a period of use, the constant vibration pulsing of these hoses is drawn through the insulation of the cable and the rubber coating of the hose until the copper conductor comes in contact with the steel braid. The steel braid is in, and away you go. So you then produce a hole. As soon as you've got worn a hole through the rubber coating of the hose, you've got a spray because it's coming out through the braid. But as soon as you get it off, you then got to issue source of the spray. These are the sorts of things they use called carbon water. You've never seen them online and so on. And they're basically just a big, they're the same chassis as you put a mover on, but with a big tank on the back. And they use these for all sorts of jobs, keeping the dust down, washing down equipment, filling up cooling systems, and also using fire tap to vary the effect. So this one's had a fire. And as you can see, the fire's not gone on somewhere down in here, in this area here. And underneath there, that's where the engine is, obviously. So looking down here, this is the view into the driver's cab. The driver's cab is pretty well burnt out. The heat will come up through the floor cab. And now we're looking down this side of the cab into where the engine is. There we go, right. This is looking on top of one of the configuration engine. And so you've got two sets of two rocker covers on each side. And this is the right side rocker cover. And then you can see it's got a large hole melted in it just there. The rest of it is reasonably intact. So here's our hole. This is the position of the hole in the rocker cover. And just down underneath you can see where all the aluminium is melted and waxed down into the exhaust manifold directly beneath. If we look, this is the bottom of the exhaust manifold here, and this is the bottom of the exhaust manifold here. Underneath here is where the oil filters normally sit. It's a series of 3 oil filters that normally sit in there. But they've gone on this one, they've actually dropped off because the aluminium fittings were melting. So they've dropped off. This is a bit of a longer shot, but you can see, hopefully, here's our section of rocker cover missing. Here's our exhaust manifold. This is where our oil filter would normally be. And you can probably see this is the area where it's damaged. So the question was, well, what's there to ignite? Normally nothing much. Nothing much. Might be some oil. So I'm thinking possibly at this stage, maybe one of the oil filters is loose and the oil is spraying up the pressure. That's a possibility. The exhaust manifold surface would probably be hot enough that close to the cylinder block to be a good ignition source for an oil spray. So maybe that's the answer. So unfortunately, I have another one I'd have a look at. So here we're looking at the same area. Here's your rocker cover. This is your exhaust manifold, and here's the filter type. So that's the air cleaner which was missing on the one we looked at. That was already fallen on the ground. So yeah, it would be possible maybe for a spray from here down there, and would you expect from this damage up above it for all we got. So I was thinking, what explanation is there? I noticed all this black stone around back here. Yeah? And when I talked to the fitters for this, and this again, the value of talking to people who work with these things, they said, oh yeah, this model, this type of engine, is absolutely notorious for oil leaks in this area here. That joint, this joint, which is the rocket carpet joint, and here, it's absolutely notorious for oil leaks. That oil runs down on top of the exhaust manifold, where it gets really, really hot. If you then add in the fact that this is working in an environment where there's constant coal dust in the air, sticking to the oil, you can imagine the sort of thing that happens. So I had a regime in place of washing these down once a week. These engines were washed down once a week to stop this build-up. This engine was washed down 2 days before that photograph was taken. The one that I showed you that caught fire was due for its wash the following morning. So I increased the frequency of their washing to about every 3 days, I think. I don't think I've had 5, 6. You know, to me, the obvious thing to do would be to do something to stop the oil leaks on your engine. Hey, for the mind. Hey, David. How are we going this time? Very good question. Yes, I do. I'll answer that in a bit of detail, actually. Most, over half of the run-on machine and give some line stuff, things like that, have auto suppression systems. But they're usually restricted to the engine part. And the detectors are all usually in a ring around the top of the engine bay. And all the nozzles are sitting around the top of the engine bay. So if you get a fire starting around your injectors or your turbo, they're terrific. They put you out no time flat. If you get a fire that starts somewhere else, or flashes from the turbo back to somewhere else, which is what about 9/10 of these do, then the suppression system won't be there. They may operate for 5 by that time to put in somewhere else. So, get back to the area we get involved in quite a bit. Advising them on how they might redesign their suppression system.
The company's listening to you.
Some of them do. That's the question. Some of them, it depends how much sway the engineers have got and how much sway the accountants have got in any given business.
Another question is how much for the risk of the danger and how much
It depends on the company and the situation. Most of them are out.
that's useful.
What's going on with that?
Seriously, work that out of money. That's what you're having on the risk.
There may be another reason why that. It may be because of the working conditions they're under. The class couldn't take the pressure or whatever. That may be something that's given to. Okay, this one here is a slightly different situation. So the front loader, but what you've got is it's articulated, so the front bit happens backwards and forwards. The engine and all the driving bits are back, and then the bit in the front of the bucket moves side to side. So that's a terrible picture of it from side on. So to your right is the front part, which is the bit that steers, the bucket on. To your left is the part of the engine, and there's no price to guessing which part the car's on. Okay, because we've got all this one down here, and coming along the hoses that way, and nothing for this inside, and follow it here. Now that's interesting in itself, because that's the end that doesn't have a diesel engine in, doesn't have a hydraulic pump in. So what is in there to actually cause the fire? So just looking back into the engine pumps just to show you there's actually too much damage in there. Now, in the front section, there's one of these things. It's a hydraulic manifold. The idea is it distributes the hydraulic fluid under pressure between different surges. Fitted under these Christmas trees. But anyway, so I know you can see, but there's obviously much worse burning around a couple of these than there is around any of the others. There's some splash marks here. spray knobs. So start looking in this area here, and what we found was there's actually, in this one here, I don't know if you can see, there's actually a slight gap. We had a failed seal in there. You see the gap here, and you can see that the seal broke on top there. So we actually had a state of hydraulic fluid. Well, that's okay. Normally all that should do is actually cause a loss of fluid, and one of the functions of the machine not to work properly. Why do we lose the fire? What ignition sources we lose? Up at the front, on the front firewall, or front wall of this area, we've got some electrical control here. But this is all low voltage. It's all well, a lot of it's 5 volt actually, the control here. But some of it is 24 volt. The solenoid is 24 volt. But they're all externally damaged. That doesn't seem to be anything greatly wrong with it. I've got one solenoid here, and I'll come to that in a moment. There was a clue in this one, which was the operator's statement. The operator described how he was using this machine, and every time he raised the bucket, it's something just drop in the sun. He raised the bucket into the blow, and he raised the bucket into the blow. So clearly something wrong with the control system on the bucket raising and lowering system. So we looked at the control, the circuit diagrams and what solenoid valve did which on these various systems, and we found out that this solenoid valve here is one of the solenoid valves, and that one actually controls the pressure that should hold the bucket in the upper position. So what happens, let's say for the sake of argument, that has failed in the open position. So in other words, the solenoid valve is being held open by the current. What would happen then? Well, the bucket would keep dropping, and the solenoid would get hot. Okay? Next question, how hot would the solenoid get? So they gave me a brand new one from their storeroom. Quick 3-minute ad from the CFA Victoria. They gave me a spare one from their storeroom. I compared it with our birth ones, I'm sure it's the same as something. As you can see, we've lost the plastic casing and everything on ours. It's the same one. So I wired it up to a power supply, and I rigged it so it was permanently energized. So it's not going to a control system to be energized, it's permanently energized. And I don't know if you can read it there. That's saying 182, and it's still on the way up. And you can see that it's sitting on a piece of wood, and it's started to char the wood. Yeah. All we had to do was so what we had here, in fact, I got this actually down to a temperature of about 270, yeah, which would be hot enough to ignite our spray of water. So it was a pretty unfortunate combination of circumstances. You have 2 forms occurring at the same time. Just to catch fire. Right. Yeah, this is a different machine. You see these on landfills, posted on that, compactor. So it's a bit of a different fire tools, this one. Engine, perfect time. Nothing wrong with the engine. Another view into the engine, a little bit of external damage. This is the engine cap, and you can see you've still got military material and good material, it's not too bad. But if you look down below in this area here, this is where all burning's gone on. And down here you've got this massive material in the belly tank. And bear in mind this thing works on a landfill. So we've got this massive material, right above it is this big rotating shaft. And of course everything that is thrown on the landfill is thrown up and gets trapped around this rotating shaft. But the other thing that can happen as well, that's the sort of material that sort of had rags and paper and all sorts in there, so that's just a goal of it. So I was pretty happy with the fresh weeding on that rotating shaft. But the other thing that I have been, I managed to catch it on that might not haven't really thought of before, because people throw out chemical containers and things like that. They actually had fires starting when they ran over food chlorine bottles that people had run out, plastic containers, that still had some chlorine in it. The chlorine gets up into the belly band and reacts with all this muck. So you can get fires starting that as well. They made a change from the hydraulics. We'll be a little bit careful with this one because the litigation is still ongoing, so you don't know where this is or anything about it. But suffice it to say, this is our estimator. These are the ones that come in around about 10 minutes. They're a bit more expensive as a kit. This is a view of the back from underneath. You can see here, I was telling you about the lockout system. This is an example of how it's locked out. The plastic bodies of the pallets have been going off. You can see that the locks are still in place. So one of the things I knew immediately about this was that A, the engine wasn't running, and B, the electrics were all isolated. So I could pretty much rule out both of those options before it started. Let's just say that again. Oh, sorry, somebody else left us here. Sorry, this is... quickly run you through that. So yeah, this is the typical fixed fire suppression system, and one of the bits of the head. So all this is store pressure, high power, and it runs through a system of pipes with discharge heads and the diffusion of into the range. Okay, so some food to start us off. Well, one food, there's some workman's colours and tools here and a forestry division. It's a used division. And this is a bit of a welding lead. Here's a more welding lead. Here's a bit of welding lead with a bit of welding rod cranked in the edge. Oh, and here's a loop. Any idea what mine we got on here? Well, the answer was, what I was doing was, there's a piece of metal that used to be underneath the machine. It's been detached, it's actually a bracket. And this is where it's detached from, on the machine. And what you've got is this is called the split ring. Split ring it rotates on. And this split ring is obviously full of grease, so it will rotate. But what it gets for during nighttime operation is everything else. But everything else in this case consisted of old shirts, cotton parts, you extracting the grease. Now what the guys were doing in fact was they were taking advantage of this machine being down for maintenance. By taking off this bracket, for one reason or another, they couldn't get the bracket, they didn't get the box, so they used an arc worker and they aired the arc out of the box to put that bracket on. The problem with doing that was they were working up the head, ladder, and all the sparks going ran straight up into that area there. But there's all sorts of that's the word. Some of them were sick, and the one I was in. So that one is still going. Okay. Who's come across rising cotton pickers? No? Yeah? Well, they normally, on most common places, rising cotton pickers to get going, they actually get a basket. Because what they do is all that cotton gets thrown up in the back of their picking, and then they get a stone or something, and a hot fragment goes flying up in the same lot, and then 3 days later down the paddock, they see smoke falling out of the basket. This cotton starts smoking. This was a little bit different. The fire wasn't up here, and around these heads either. Where it was inside this area of the picker. It's just looking to drive the cab. We did have a bit of damage around the front of the turbo charger. There was a bit of belching there. But that was actually later explained in terms of the way that the fire developed and some material falling into that area and put out the fire. What we did there though, back here, so the engine's here, and you look back, where the batteries are. And you can see what you've got here is the main battery code running up here through this clamp, just an ordinary cable clamp. But it's just there, there's no sign of any rubber, plastic lining or anything like that. So we went back to the local dealer, and looked at a brand new one in the workshop. Sure enough, it was just a bare metal clamp around the battery cable, which also had wiggle room. And you can imagine sort of the vibration these things get. Everything's wrapped in a banging around. This one had done about 300 hours since the previous service. So it was just waiting that. And as a result, what we found on this one, what we found when we looked at the one in the manufacturers, in the importers, sales group, they actually issued a recall on this machine, this model machine, and they fitted all of their rubber grommet around the cable on through that.
Was there any art down there?
Yeah. Just go back, you can probably see it on the actual, that's the log at the end of the log. Okay, service truck. Again, this is on my side. The service truck is one of these sort of hybrid things. It's halfway between being a road vehicle and not being a road vehicle. So it's a bit like a sort of a big prime mover or a big truck with stuff that they replenish the big truck and so on. And instead of having a normal transmission between the engine and the back, it's also got this one here. So you've got the normal engine, the normal gearbox, and then you've got a couple of extra hydraulic pumps which drive pumps for like the diesel bowser and the hydraulic valve on the back. So you've got all these equipment in there, so that's a little question to start with. What we did have was a lot of damage directly even behind the fuel tank. The fuel tank here. A lot of damage coming up behind here. Couldn't quite work out what that was if you had a fire starting behind there. The service burning on that motor we took the tank off, and behind the tank you can see, sorry, that's the tank itself. Just trying to get through the quick, that's it. So these are the diesel fuel lines here. Braking the string, obviously the input of the brake is just burning, just leaving the white. And as you can see, again we've got a clamp around here, just a metal sort of ring, in fact. So we're going to look at an identical undamaged one, and here you've got, these are the fuel lines, high pressure diesel running through those, and that is just basically that piece of timber sharp edges. Now, you're not, but they pay $250,000 for a piece of kit. You think the manufacturer would do a bit better than put a bit of timber sharp edges on the diesel ones. Personally, let's bring the changes here. This is all good. It's only like the D6. This was on a land reclamation project up in Newcastle, where they've got some old industrial land over there, and they've got to build a housing estate. I think they've had to stop that now because they do something illegal. We've got quite a bit of burning in and around the cab of this one. But not much anywhere else. So we're burning in here. Right, the engine area is not too bad. See, this is the engine. See all these diesel injector fuel lines are all right. So look at the other side of the engine, and all the damages come from the outside into the engine. Whereas the cab is completely burned out. Right side. That was a bit strange. The circumstances of this one were the guys found out that workers for the still subcontractors out, which is good. So I wonder if I got this guy up. He turned up to work at 10 o'clock in the morning, and that makes absolute torrential rain. They couldn't do anything on the soil, so they had to live it, 4% rain. And then about 6 o'clock that night, still in the torrential rain, neighbours reported this on fire in the middle of this land reclamation project, nothing around. And neighbours reported this on fire, fire goes down, got 2 trucks bogged down, and the next morning, by an amazing coincidence, another bulldozer under-operator turned up and said to the boss, I think he had some trouble. Do you need another bulldozer? I didn't know that. But, so I looked at this, what I found was that on the step, there was actually on one side of the cab, there was broken glass that had fracture factors on it that did really look like thermal fractures. And inside the cab, just inside the cab, was some nice clean broken glass. And there was a very strong smell in this area here. So I took a bit of that and essentially put on a wall and had it analysed. And lo and behold, it was petrol. Yeah, I don't know about you, but I can't be the legitimate reason to have petrol in the capital of diesel bulldozer. So that was written off as a deliberate fire. And I think the suspect might have been the other bulldozer driver. So I really didn't have anything. But I thought I'd show you that because you can have deliberate fires in machinery as well. And you want to finish? All right, keep going. Yeah, okay. All right, so another excavator. I'll point you this one for Willie. Okay, so this one, that's not actually running away, it's just trying to get out of my camera shot. So this is another one of these excavators. And what we had was, again, I don't know if you can see, all the fire is up in this area up from there. Got a lot of burning up all of this area here from the top. And when we look down into that from above, this is the side of the engine. We've got this part of the front cover here, that's what you're talking about. And if you look down here, you've got all the damage in this area here where the wiring is. So it's a bit closer. Now what you've got is there's two, because it's such a big engine, it's got 2 starter motors. Turn it over. So you've got 2 starter motors here. And then you've got a bit further back. There we go. A bit further back, but this is, which is a prelude motor. So the idea is that when you start the engine up, this is a big engine, this thing spins round first, pumps the oil pressure up before the other 2 kick in and start turning the engine up. Otherwise, you can't turn a dry engine. It's much harder than it probably be. So that's the idea. So this is on an intact one, and you can see here, this is the prelude motor, these are the 2 starter motors. And you've got all this cabling goes between the 2. And these are the starter motors that came off our damaged one, I don't know if you can see, all this wiring here is heavily off. That starter motor is actually jammed, completely jammed solid. One of the issues we identified with this was that the cable they used for the starter motors supplies from the battery was 75 square mil cable, which was actually not enough for the rated cranking current when you start these engines up. So the manufacturer was actually putting on cable was rated too low for the job with respect to the starters. Then we looked at this motor and found that was absolutely steel solid. So what we're thinking, and this was the thinking was that the engine was starting up, but then this couldn't disengage. This starter motor couldn't disengage, so it was still drawing current all the time, and you wouldn't know because you wouldn't know what the diesel engine running. You wouldn't know that starter motor was running. So that would draw overcurrent, more current than this cable was rated at. For a short period, it can get away with it. But over a long period, what that then does is softens the insulation, and the insulation starts to fail, and where you've done that to here, you can see where these different cables overlap each other. If you imagine what starts to happen there, once some of that insulation starts to soften, fail, they're all going to come into contact with each other. I'm pretty sure that's what happened here. It wasn't absolutely cut and dry, that one. The one thing we did manage to get them to do was to retrofit all those sort of excavators with the right rating and night screen that is. So that's just a fuse box that's supposed to protect. This is the end of the cable, the terminal on the end of the cable can actually specify what the size of the cable is. So that's not my evidence, it's the wrong size of it. This fuse is supposed to protect those cables. That carries these 75 square mil cable ratio, 220 amps or something like that. And the fuse is about an amp fuse. So it wasn't pretty much used as a circuit protector. Okay, very briefly. This is more typical of the sort of thing you probably come across every day. This is a prime mover, typical prime mover for a big up or a road train. A lot of damage here around the engine, as you can see. It's worse on this side. And if you look here, this is the turbocharger up in here. So the exhaust comes out the side of the engine here, comes up to the turbocharger, and goes out to the exhaust system here. This is on the side of the engine, you've got these are the diesel fuel pump here. So these are the pipes for the injectors. Nothing wrong with those. Down here, this pipe here actually pumps the engine oil up to the ancillary side of the turbo. Following that pipe, following up and up to a point where it has one of these banjo fittings on, banjo fittings, and what we found was the seal on that cable was white, so there would have been oil spraying from there. And that's located, that's the next one to it, and that one runs up to the top of the turbo. You can see this position here. This position here, sorry, and this one is only that off from the turbo outlet. So once you start to spray it without, so it's just a simple hurry. And through this one, because I use many other years, this is one we do together very recently. This is a haul truck again, a bit different this one, but again, I don't know if you can see, these are running patches of oil on the roadway. This line of cones becomes apparent, and we'll see what that's about in a minute. The driver's description of this one is he's driving along down the haul road, all of a sudden there's an almighty bang, so he hit the brakes, and by the time he came to stop, there was a fire coming out up into the cab and around him and went down. So, looking back up the road, all this oil, and in another year, I want to show you all of this because it's there's little scattered bits debris. And this line represents about the furthest back, so the initial bits of debris that were flung out from the machine. And here's one of them. So it was found in this rock pile at the side of the road, and this is actually a big end bolt, which is completely sheared off. So everyone knows what a big end is. Now here's a bit of bearing shell. There's another bit of bearing shell, and a bit of it. And there's a chunk of crankcase. But all of these were scattered all the way down that roadway. So this is a bit of an unusual fire. The fire was caused by the mechanical fault. What we've got here, if you look under the truck, we've got a hole in one side of the crankcase, and you can actually see the bottom of the crankshaft. And on the other side, we've got a massive hole there, and remains the big end now. So basically what they had was a big end bolt let go, smashed a hole inside the crankcase, high pressure oil, hot oil vaporising, leaking about everywhere, and again, we've got no human conditions here. We've got the turbocharger, you've probably got electrical things shorting out as a result of being hit. like dying every, and you've got the hot parties themselves which are popping up to all of this. So summarising, most of the things that we come across can be pretty much summarised as this. Most of the fuels come from pressurised fuel oil mix. Most times, on average, on the place. A lot of the emission sources are involved in adequate separation from services. Now, I've already mentioned about lagging. Some people put the lagging on there will actually stop the ignite diesel hydraulic oil testing one. If you can put if they put a physical barrier in there, and that will, actual solid level form. Inadequate restraint of electrical cables is a classic you see over and over and over again. Accumulation of combustible contaminants, so that was the compactor and also the water truck having the oil and coal dust gathered around the exhaust fan. And of course, we still need parcels as well. Are you seeing any change in the machine? As a result of your manufacturers taking it on board? I'd have to take credit and say that the student latest, I think as things happen around the world, yes, they do. I think I'm the only person who does this. Yes, I think they do. The machines are getting more reliable and less. I think that's fair to say. One of the problems that we'll probably see in the future is that how much higher level automation on them now. So it's much more electrical and electronic equipment than they ever used to. I'm just waiting for the first one on the driverless one. Because who's going to report it? You can be out there and do the field for a burning light. Nobody even sees it. There's nobody there. Anyway, I'll just wait.
Was there any particular country where the manufacturers that's come from the problems seem that the Fiat, at least the parking planes, has a lot to do and the slackness where they put it in.
Well, there's really only probably two countries actually manufacture this equipment. And they buy a lot of the components from another country. But the two countries that buy most of it is the USA and Japan. And the country that supplies all the components is China. I think that there are probably differences in regulations between the USA and here or the USA and Europe. They do make certain, there are certain things that make certain markets and other markets. But I mentioned to you one I went to, one of the ones I went to wasn't in this country. That was a long way away from here. Their standards were very, very different. And if you go further away still, if you start getting into some of the African or Indonesian mines, then safety goes out the window. It's just keep running to the give up. Any other questions for Jim? Right. Oh, thanks very much, of course. Thank you. For me as well, even though they're complex, large machines, the fundamentals are the same. Get those people that saw witnesses, that can see what happened, try to identify that area of origin, identify the emission source, identify the fuel, and hopefully get a result. Thanks for your attendance. This is the last one for the year. Next year we're planning another 6. So in February, it looks like we should have Morgan presenting on the Blackett Hill fire and investigation, the research firm conducting that. So we'll have information about that, but we're looking for another 5 after that. So if you do have an idea or you know that a presenter would have a great sort of presentation for us to do an education night, certainly let us know, and we'll put together a committee, we'll get together to decide on where and when those ones will be. So thanks a lot.